Okay, all right. So I wanted to show you how to do these t intervals on your calculator. Okay, so I got this particular problem is what was asked about. So I'll show you how to do it with this one. And it's a lot like finding the z intervals, but I have to deal with the degrees of freedom. So here, I guess this is our formula, right, for getting a confidence interval for the mean. X bar plus or minus E for the error, where the error is this guy. S for the standard deviation, and for the number of things you have, and T star is your critical value there. And so that's going to come from the type of confidence we get. So if it's a 90% confidence, I suppose that means I have 5% in either end of the tail. So I guess I'm looking at the left bound at 0.05, and I need to know my degrees of freedom, which is 25. Again, it's just like the inverse z, only it's an inverse t. So you say you have a t inverse button. So under distribution here, same spot where I got the inverse norm, the normal CF, I have an inverse t. So I'm going to type him. I need the 0.05 because it's half of 10%. Then I just got to put in comma degrees of freedom. So if I had 26 trials, degrees of freedom is in -1, so I guess it's just going to be 25. And it's going to give me 1.71. And we take the positive value. So let me just type this in here. Right? So they say t equals 1.71. All right, so now it's just a matter of putting everything back in here, right? So let me see. Just type everything in. So they say E equals 1.71 times S, which is this 105.28 divided by the square root of my n, 26. Oh, shoot. And let me see, what's that number here? So times 105.28 divided by the square root. Nope. The square root of 26. Oh, because of negative. Okay, I just get rid of negative. So my error is 35.28 or 27. So I got to go x bar plus E, x bar minus E. What was my x bar? So I got to go 756.24 plus 35.27 and 756.24 minus 35.27. And what do I get? So 756.24 plus 35.27 is 791.5, and the minus is 720.97. This guy is 791.51. So I can say what? We are 90% confident that x bar is between 720.97 and 791.51. again, exactly what does that mean? I guess that means if I did this experiment over and over and over again, I'm going to get a whole bunch of different intervals, and 90% of those intervals are going to contain the actual mu, the actual mean, which I guess is speed of light in this case. But there is one little tricky thing to this particular problem, is this little bit right here. Was when he got his speed of light, he subtracted 299,000 from them. So to get my speed of light, I have to add the 299,000 back onto it. So plus 299, 1, 2, 3. So it's like my lower bound is going to be this guy. Let me write him in. Oh, shit. 299,720. 299,720.97. And what was the other one? 791. 1.51 plus that same number, 299. 1, 2, 3. And that guy. 299,791.51. So that extra added little tricky thing there on the end. Okay. Here, actually, I want to show you one more thing, because we can actually go through. Now, a lot of times they're actually going to ask you for that little t-star somewhere in there, so it is worth our time to go through and do this whole t-inverse. If they ask you the parts, you want to go through the whole process like this. But the calculator can actually do all of this. So if I clear all this out here, let me clear this too so you can see a little better. If I go into stat, and I go over into tests, I should have a t interval here somewhere. There it goes. T interval, it's number 8. They gave me the stats. I was typing in, the X bar they told me was 756.24. The S they told me was 105.28. And my N was 26. And I wanted to be 90% confident. And you see, it just spits out those numbers that I got right here. Now, I still got to remember I got to add on. So you can actually cut out that whole t-inverse step and putting another formula. You can go straight to this interval if they don't ask you for the intermediate steps. The other thing I guess that I'm more concerned about, again, is exactly what this means. So with 90% confidence, the speed of light is between the upper and lower bounds. Okay, that's, again, I guess exactly what we said. But I guess more interestingly, any measurement of the speed of light will fall within this 90% of the time. And that's not what it says, right? Again, what it's saying is if I kept making all these intervals, 90% of the intervals would capture the true mean. The confidence interval contains the true speed of light 90% of the time. No, not this confidence interval. We're talking about all confidence intervals. And this is for all samples. 90% of them will have a speed of light that falls within this confidence interval. And again, not true. We're not talking about the samples, talking about the confidence interval. This one, I guess, is saying it pretty much is exactly 90% confidence. And I guess the rest of this is, looking at things. But I guess the main thing was I can put these things in the calculator. So, I don't know. Hope that helps. If it doesn't, let me know.